And you're about to see why. It's not, how many of you guys have crunched one of these by hand before? It looks like a couple of you knowingly, yes. Yes. I want to use Ernie's because Ernie's going to be the easiest one to calculate. Bert's going to be more tedious, and we're going to let technology do it for us from then on out, because it really does get quite annoying as far as mathematics goes to calculate these things. So let's figure out, and this is the only measure of variation I want to talk about in this class, really, honestly, because it's the only one you're going to read about in journals. And if you can understand it, and that's the definition of it, if you can keep that in the back of your mind, then we're golden. Like I said, average, median, mode, you guys had that within 10 minutes. It's going to take a couple days for you to get fluid with this. So that's just because it's not a simple concept, and you're about to see why. Who's that mom again? So let's figure out how to calculate the most popular measure of spread. Of spread. So this is a T-table approach, or actually it's more like an M or a super M table approach, but we'll get to that in a second. I'm going to put the data in here. So these are Ernie's. We'll do Ernie first. His scores, 82, 79, 81, 80, and 83. Yeah, I got those right. We're going to do Cole's column next. We're going to figure out the difference between each of those data points and the average. But we're going to go one step further. Instead of looking at distance, we're going to look at difference. And Cole's like, wait a minute, that's the same thing, distance and difference. But it's not. We're going to pick up something here that's a little better, in my opinion, than just pure distance. What is 82 minus the average of 81? 1. What is 79 minus the average of 81?
2.
Negative 2, right? And the reason I like this computation is because not only do you get the distance, but you get the placement of where it is. Because if all you have are these displacements, you now know, is it above or below average? That's 2 points below average, that's 1 point above average. This guy right here, at average. This guy right here, a point below. This guy right here, 2 points above. All right. So that's good, yeah? Let's average it. But let's average it. Corey's taking it all in. Good for you, sir.
Wasn't that 1.2?
That was the average of the distances without looking at the positives and negative signs. This is, yeah, I want to average these values with the negative signs in there.
It should be 0.
Ernie has no deviation. Ernie has no deviation, right? Right?
Yeah.
But he does have deviation, doesn't he? I mean, granted, you guys believe that he has less deviation than Bert.
Right.
But he does deviate. If he had no deviation, what would every single one of his test scores have to be?
100.
Well, or all 81, or all 61, or all 0. That would be consistent. He's awfully consistent and awfully awful. Or if he gets all hundreds, he's awfully consistent and totally kick butt. You'd accuse me of cheating, wouldn't you? Yes. No. It's okay though. No.
Not if all of them are.
But if he had 0 deviation, all his test scores would be the same. And here's the interesting thought. I'm going to pull the screen down for just a second. Do the same thing for Bert. That's okay. It's not done yet. It's not done yet, Aaron. Look at Bert. Look at the distances between Bert's scores and his average. His average is also 81, correct? This score is 61. 61 to 81 is negative 20. Negative 20. Okay? I'll just put that in for a second. Negative 20. His next score was a 68. What's the distance from 68 to 81? Negative 13, I think. His next score was 82. That's positive 1 over the average. His next score is 94 from 81. I believe that's 11. Yeah, that's 11 points. Next score, 100, which is 19 up. Is that right? 19 up.
19 up.
Was it 13? Thank you. Oh yeah, from 81. That's exactly right. Thank you, Alicia. Friends, if you average these 5 numbers,
What's a zero?
what do you get?
No.
You get 0 again, don't you?
So no deviation
So then you would say Bert has no deviation. At which point, it was just like, this is ridiculous. How can they both have 0 deviation? And the only answer is, they don't have 0 deviation. As a matter of fact, this is such a fun mathematical fact, I'll offer you extra credit to prove it to me. Why, for any data set, if you do what we just did, it'll always sum to 0. They will always sum to 0 if you do that. No matter how varied the data set is, no, don't tell me now, pick it up, pick it up. It's worth extra credit. If you look in the extra resources page for measures of variation, you'll see it near the bottom. It says mathematically or otherwise prove it to me. Good, 3 hands shut up. Good for you guys, good for you guys. It's worth extra credit, so we'll all turn. Okay, good for you. So obviously, we can't just use this column, can we? So, what can we do to fix it? Take a 5-minute break. Yeah, because I'm looking at the clock and I'm looking at the faces, and Taryn, I want to hear from you, I do. But in 5 minutes, yes? Please, 5 minutes. You're starting to get that glazed donut look. Yes, let's take 5. Let's flush some air.